A single pickup truck, a cloud of vapor, and 15 people dead. This is the brutal science of why gasoline is quite literally the most dangerous liquid in your life. Most of us pull up to a pump every week, pull a plastic trigger, and watch a clear liquid flow into our cars without a second thought. But what you are handling is a chemical cocktail so volatile it took a 10-story tower of fire and pressure just to create a single drop. We think of it as just filtered oil. The truth is much more dangerous. On the 23rd of March, 2005, at a refinery in Texas City, a single false reading on a level transmitter turned a 170-foot distillation tower into a massive bomb. 2 million liters of hot, flammable hydrocarbons overflowed, creating a vapor cloud that incinerated 200,000 square feet in seconds. This is the reality of the fuel that powers 800 million vehicles across the planet every single day. Welcome to Everyday Simple Science with Ray. If you're new here, subscribe right now, because this is exactly the kind of hidden science we break down every week.
To understand the danger, we first have to understand the staggering scale of the system. We burn through 7 billion liters of fuel every 24 hours. But gasoline doesn't just exist in nature. It's hidden inside porous rock miles beneath the Earth's surface, and finding it requires a process that is essentially giving the entire planet an MRI scan. Geologists use seismic surveying, blasting powerful sound waves into the Earth to map out ancient rock formations that haven't seen the sun for hundreds of millions of years. When we finally find it, we don't just punch a hole in the ground. We use drill strings thousands of feet long, cutting through granite and shale, while circulating a specially formulated drilling mud to prevent a blowout, a catastrophic rush of high-pressure fluid that can trigger an immediate inferno.
Once that crude oil is pulled from the depths, it is essentially useless. You cannot put raw crude in your car. It's a thick, viscous mixture of impurities, sulfur, nitrogen, heavy metals. It's a raw material rich in potential, but trapped in a molecular prison. To unlock it, we send it to a refinery, a sprawling industrial city that can cover 4,000 square miles. Here, the crude oil is superheated to over 700 degrees Fahrenheit and pumped into the heart of the facility, the distillation tower. Think of this tower as a giant vertical oven that takes crude oil apart and rebuilds it. As the heated oil enters the base as a vapor, it rises and cools. Because different molecules condense at different temperatures, they separate out like layers of a cake. The heaviest, dirtiest compounds, like asphalt, drop out of the bottom. Moving up, we get diesel, then jet fuel, then kerosene. Near the top, where it's coolest, the lightest molecules condense into gasoline.
But here's the problem. A single barrel of crude only naturally gives us about 19 gallons of gasoline. That isn't nearly enough to keep the world moving. This is where the brutal science really begins. To get more gasoline, we don't just filter the leftovers, we shatter them. Using a process called catalytic cracking, we take those heavy, long hydrocarbon chains that are too thick to be fuel and blast them with heat and pressure in the presence of a silica or alumina catalyst. This literally shatters the heavy molecules into the lighter ones your engine needs. But if catalytic cracking is the brute force of the refinery, hydrocracking is the VIP equipment. It is the refinery's most important and expensive secret, operating at a mind-bending pressure of 160 kilograms per square centimeter. In this high-pressure environment, impurities like sulfur and nitrogen are stripped out completely. Hydrogen is then forced into the molecular chains to create a clean-burning, high-performance fuel that meets modern environmental standards. Without this single piece of engineering, your car would be spewing black soot into the air every time you drove. If you are finding this fascinating, do us a favor right now. Hit the like button. It tells YouTube this video deserves to be seen by more people. But we still aren't done. Even this shattered, cleaned oil would destroy your engine. If you used pure, unrefined gasoline, your engine would experience something called knocking, where the fuel ignites too early inside the cylinder, essentially trying to blow the engine apart from the inside. To stop this, engineers use a process called isomerization, taking straight-chain molecules and reshaping them into branched molecules that are far more stable under pressure. This is what gives us the octane rating you see at every gas station. A higher octane number isn't about more power. It is a measure of the fuel's resistance to premature explosion. It is a safety rating for your pistons. And then there is the seasonal secret that almost nobody talks about. The gasoline you buy in December is chemically different from the gasoline you buy in July. In winter, engineers blend the fuel to be more volatile, so it vaporizes easily in freezing temperatures for a quick cold start. Use summer blend gas in a blizzard, and your car might not even turn over. On top of that, every batch leaves the refinery carrying a specialized additive package: detergents to clean your fuel system, anti-knock agents for performance, and corrosion inhibitors to stop the fuel lines from rusting from the inside out. The final journey is the most dangerous part of all. Every day, 1 million gallons of this volatile cocktail roll out of refineries in tanker trucks, essentially moving bombs. The metal body of a tanker builds up static electricity just from driving, and a single spark near the loading valves could trigger a catastrophic explosion. To prevent this, every truck must use grounding cables to discharge that static before a single drop of fuel is transferred. Now, recently you may have seen viral videos claiming you can make gasoline from thin air using a device the size of a refrigerator, filtering CO2 from the sky and turning it into fuel at home. Here is the scientific reality. The energy density of gasoline is so massive that building it from scratch is incredibly inefficient. Producing just 3.8 liters of gasoline from air requires 75 kilowatt hours of electricity. That same electricity could power a modern electric vehicle for over 600 kilometers. Gasoline isn't just old technology. It is a miracle of nature and engineering that we are only now realizing is nearly impossible to replicate cheaply. The next time you pull that trigger at the gas pump, remember what you are actually holding. A liquid pulled from miles underground, superheated to 700 degrees, shattered at a molecular level, precision engineered to be just stable enough not to blow up your car. It is a century of human ingenuity, a high-stakes balancing act between power and catastrophe. If this video changed how you see the fuel in your car, subscribe to Everyday Simple Science with Ray, because next time, we are going into something even more surprising hiding in plain sight. Like and share this video, turn on notifications so you never miss an upload, and click the video on your screen right now to keep learning. Thank you for watching. We will see you in the next one.